All right, so I think this is recording. Let's take a look at this word problem. We have a box of cereal is supposed to weigh 13.8 ounces, but it's acceptable for the weight to vary as much as 0.1 ounce. Write and solve an absolute value inequality to find the range of acceptable weights. All right, so what do we have here? Well, I'm going to start with a picture, and I'm going to draw a number line. And I'm going to try and figure out what my solution set is on this number line. This box of cereal, if everything in a perfect world, every box of cereal would be identical and they would all have 13.8 ounces of cereal in it. But we know that that's not the case, that it might be a little bit off. But it looks to be pretty accurate because the 0.1 ounce is not a very big deviation away from this center, away from this middle. If I add 0.1 to this 13.8, I'll be at 13.9. If I subtract, I'll be at 13.7. Now, I'm going to include these endpoints in my solution. And I'm going to say that a true box of cereal, it has the weight that's somewhere between those two values. So hey, that's my solution. When it said to solve, find the range of acceptable weights, I've actually found the range of acceptable weights without even setting up the absolute value equation. But see, it wants us to connect this together. And I think it's acceptable to work backwards like this to draw our solution set on a number line. So now I know that when it comes to absolute values, if I'm shading in the middle, my arrow is pointing towards the absolute value. Since I've included my endpoints because they were actually 0.1 ounces was acceptable, I have less than or equal to. So I don't know, my x is my variable x is the unknown weight of a box of cereal. Could be 13.8, could be less, or it could be more. We know that x minus this central value, 13.8, is only going to differ by 0.1 ounces. Okay, so here's my absolute value inequality that describes this solution set. Let's double check it. Let's algebraically solve for this. So let's change this to negative 0.1 less than or equal to x minus 13.8 less than or equal to positive 1. Let's add 13.8 everywhere to all three sides here. When we add it here, we get 13.7. The negative and positive 13.8 cancel. And here I get 13.9. Remember, this has units of ounces. So here was my absolute value inequality that modeled this situation. And here is the acceptable range for the weight of my box of cereal. So hope that helps, and I will talk to you later. Bye.